Welcome to IT Pro TV. I'm your host, Don.
Coming at you live from San Francisco, California.
You're watching IT Pro TV.
Hello, everyone. Welcome back to another exciting edition of IT Pro TV. I'm your host, Vaughn Smith, and this is our Cisco Cloud Fundamentals series. And in this episode, we're coming back in a part 2 of our block storage access. And here to tell us all about the wonderful things we're going to learn about today is Mr. Ronnie Wong. How are you?
I am doing well, Vaughn. Thank you again for joining me as we continue on our Cisco fundamentals here for, of course, cloud. I kind of did that out of order, but you kind of get the idea here as we start to see. We already did a part 1 on, of course, block storage access, where we covered some of the basic technology that we should all be familiar with. And what we're talking about there, what we did talk about there as a way of review is just we actually ended up taking a look at some of the technology that we're fairly familiar with because they're really localized on our own machines, right? We talked about the idea of IDE, or you might hear the term PATA, P-A-T-A, as well as serial ATA, that those are the ones that actually do provide for us block storage access on regular desktop computers as well, okay? Then, of course, as we started moving and started realizing that storage is no longer limited to just a single machine, we started moving a little bit more towards the idea of understanding the use of SCSI and the ability, of course, to expand those drives. And we talked about SCSI technology fairly heftily, where we showed you the demonstration, of course, of being able to daisy chain devices together and make them work in the way that we wanted to. And then all the technology that spawned from that. And now, of course, we still have another block storage technology that we need to talk about as well. Now, when we ended the previous episode, we had just really finished talking briefly about the idea of iSCSI. Okay, iSCSI essentially is an implementation that's almost reaction. I shouldn't say it's 100% reactionary, but fiber channel itself, at least in those days, was insanely expensive. Okay, so most networks, small networks, even though they wanted to implement something like it, the price of the technology, along with the additional storage devices, and of course, the ability to kind of conglomerate that all together in a small business is probably a little bit too much for most of the people that were probably supporting with 1 or 2 people on staff, as the IT department. So, of course, the reaction to that was, well, can't we just run the same thing, but not use fiber channel? Well, iSCSI was essentially the way to be able to do that. And so it allowed us to gain access to the same types of technology that we would normally see in fiber channel, but using the IP network instead. So we were actually able to use TCP and, of course, even UDP at times, but usually TCP, and, of course, using IP as our transport protocol that we would use instead of using the fiber channel proprietary technologies, okay? And that was actually the key for us when we started to think, okay? Now, the other technology that I mentioned there was the ones that we're really focusing in on here, which is fiber channel. So we need to at least talk about the basics of fiber channel and understand them as we get ready for this exam too. Now, I'm not going to tell you we're going to have a fiber channel primer so that you understand everything that there is to know about fiber channel, but at least the top overview of some of the things and the terminology that you should be familiar with, as well as how some of it works. That is what we're jumping into, is what we're going to do. Now, Vaughn, as far as fiber channel goes, okay, this is kind of spelled at least differently for us here in the United States. It's not F-I-B-E-R, but it's F-I-B-R-E, and then, of course, the word channel after it, and that's normally when you actually see it, that's how you can distinguish that it's a proprietary technology. So when people first heard about it, at least I remember when people first started talking about it, I was like, oh, fiber channel, that's got to mean that it uses fiber optics, okay? Well, it's not that. It's the idea that this particular technology is proprietary, costs a lot of money, very high speed, and pretty much the gold standard. And even today, it's probably the main proprietary SAN protocol that's used because it's so reliable and it does a lot for us. But it is highly proprietary and it's super high performance in what we need. But the time that fiber channel came out and the way that it ended up working, it never fit neatly into the categories that we would normally define in networking, such as the OSI model, okay? So, Vaughn, the OSI model, do you remember that idea of the OSI model?
I do. All people seem to need delicious pizza.
Yes.
That was our little acronym or little saying. What do they call those?
Yeah.
Remembrance
pseudonyms.
things.
Yeah. Something like that, yeah.
The thing of we had a application, session, The
presentation session.
presentation, yeah, I know.
Session.
Yeah, there's the data layer, there's the transport layer, there's the there's a couple. I know I'm going out of order,
Yeah,
but
no, that's fine. But see that for us, right, in terms of just regular networking, we kind of go in order, and we understand that it's really just a model. It doesn't have to go in order, but it helps us to explain the process of networking, how that ends up working well. In Fiber Channel, they didn't follow along so easily.
oh well, that's kind of weird. You're kind of breaking the whole system, but everything's kind of based on the OSI model, from what I remember in networking.
Yeah, that's what you would think, is that, hey, everything should follow in this category. Well, when Fiber Channel came out, they decided, like, look, that kind of works, but even the OSI model, right, most things even break it, so it's kind of more of a rule of thumb. You don't have to, but it at least helps everybody to be on the same design is what it does.
And that's what you're saying. They're highly proprietary.
Right.
So far as like they made their own OSI model.
Yeah, essentially that's what it came down to. And this is strange for us because we understand the idea of the layering if we've been through the OSI model and you've been studying it. Of course, at this point in your networking career, you should actually understand the OSI model fairly well. And now, of course, Fiber Channel comes along and says, yeah, we're not going to use that. So what do they use? They use their own particular type of layers that they do. So let's take a look at my screen, and I'll go ahead and put these layers up here, okay? Now, I've gone ahead and just typed them out for us. I kind of typed them in the different order than what I'll have on the show notes. For those of you that are IT Pro TV members, they'll be directly in the show notes. But if you're just watching this, it's right here on the screen for you to be able to take advantage of. So when you're using Fiber Channel technology itself, it falls in this particular manner in what you see. So instead, what we have, of course, are Fiber Channel layers, and we have FC0 all the way through FC4 is what we have. And each of these layers is important in the very fact that it does kind of follow what the OSI model would be, but it's not exactly as neat and as structured as the OSI model. So here, let's take a look at each one of these layers. You don't have to memorize them all, but you do need to know that they do follow in these layers here. For example, when we talk about just regular OSI model, when we talk about connecting devices together, right? We use cables, we use connectors, we use electrical impulse, we do all that. That's going to be FC0. That's what it's going to be. So media connectors, transmission parameters as well. So even though it doesn't go all the way down to like the bit layer at times when we start talking about like at the OSI model, it does sometimes hit that where we talk about the media and the connectors that we're doing. But notice they also talk about parameters for the transmission to go on as well. Okay, that's where we come into FC0. Now, right above that layer, of course, is FC1. And FC1, it begins to get a little bit stranger for us. This actually includes what we call error control and even encoding. Now, Vaughn, when we talk about the idea of encoding, okay, here's some of the terminology what you should be familiar with that's only really explicit with the idea of Fiber Channel itself. Vaughn, have you ever seen anything like this, 8B/10B or 64/66B?
I can't say that I have there, Ronnie.
Yeah, most of us probably haven't, and that's no shame, but just kind of realize that if you're actually going to be able to kind of glean from this, right? What they're saying is that the encoding happens a little bit differently in this way, okay? So the connections that we have, it depends on what we're actually transmitting here. So on 1, 2, 4, and 8 gigabit types of or transmission speeds, right? So when you actually talk about that gigabits per second, well, the way that they encode the data is what they call 8B, 10B here, okay? And what that means is for every 10 bits of transmission, it's going to be represented by an 8-bit symbol. It's kind of weird, okay, in what that means. So all the symbols that are actually used here are actually going to be represented in 8 bits in terms of the 10 bits that are actually sent at a time. So every single symbol that's actually there, that's what it's going to be. Now, notice that they actually have, well, a much higher number here, 66, and then 66B here, 64, excuse me, and then 66B. Well, this means for every 66 bits, it's going to use a 64-bit type of symbol instead. And this is when we start getting super high transmission speeds of up to about 16 gigabits per second is what we're talking about there. So this is all about, of course, making sure that we can encode the data the way that it needs to for super high speed transmissions. The bottom end of Fiber Channel for us, right, really is that idea of 1, 2, 4, or 8 gigabits per second. Now, in today's world, that doesn't sound like something that's super, gigantically fast at times, but it is. It's ultra fast. And then when you get up to the 16 gigabits, it's really fast as well. Okay. But in the days that when it came out, when we were all running like 100 megabit, you can tell the difference right away, right? Just because of the encoding itself, it actually can transmit a lot faster and has a bigger pipe in what it does. Once you get up to FC2, now we begin to structure the frame and we begin to sequence all the bytes that are also going across as well. So notice that for us here, FC2 is all about that idea of frame structuring and also byte sequencing across fiber channel. Okay, then that prepares it for all the other services that need to be enabled for it to work as well. Security capabilities, other services. Let me make sure I'm telling you right here. Time distribution services that may be there. All that has to actually work the way that we need to, and ultimately, then that helps us when we start communicating with fiber channel. Because now, once we get up to the realm of the FC4, this is where we get into ULPs, which are upper layer protocols. And this is what allows different technologies to begin to be able to use fiber channel as well. So it allows for things like mapping between things like SCSI and also IP, as well as fiber channel technology layers. And then this one right here, Vaughn, this is kind of an unusual acronym for us. Have you ever seen this one? SBCCS.
There's a whole bunch of letters up there, Ronnie, that I am really not familiar with at all.
Yeah, this is weird. This is IBM's proprietary way of doing things, and this was actually IBM's single byte command code set. Yeah, go figure. So, some of this stuff, once again, these were the upper layer technologies that were actually used as well at the other end of it, right? So you and I might think that it's the same analogy, right, between the physical layer all the way up through the application layer. Well, to a point, it sounds like that, right? ULPs, these almost sound like application layers, but they're actually different devices and protocols up here. So for us, right, IP would be on layer 3, and that should be all the way down here. But you see that there's different services that are deployed in between. So it almost follows, but it doesn't exactly, and they're kind of a little bit out of order for what we are used to actually being able to do, okay? So that's an important technology for us. So Vaughn, some of the weird things that we want to make sure that we can at least identify with, right? So I think for me, if I thought about it, right, for something like an exam that I might be facing, okay, picking out a few words and understanding what's at each layer is probably a good thing, okay? So for me, I know that what would zero in on my mind, because I'm like, if they're going to trick me anywhere, it's this 8B, 10B encoding stuff, okay? It's the idea of 64, 66B. They're going to expect that, hey, if I've never even heard about the technology, I don't even know what that means. Okay, I can see that. I understand that particular idea. Also, if they throw in something like SBCCS, right? If you've never heard about it, never seen it, you might think that stands for what? Something that might be, not exactly the same as what you think. But the weird thing that kind of throws you in here, right, is IP. Because all of us are coming from the OSI model, right? We wouldn't think that IP and something like this actually are, the same layer in the protocol, but for fiber channel, it is. Okay, so that's kind of the unusual thing. For us, when we think about security, we might actually even put that above, the upper layer protocol as well, or even knowing what ULP means. These are some of the things that we should feel comfortable with if we're kind of quizzed on something like this. Again, I can't tell you that you're going to even get a question on, okay, because that would be wrong for me to tell you. But what I can tell you is I can see where, if I was getting quizzed on something like this, it's those kind of little details where it's like, I know how they're going to get me here, but they're not going to test you heavily on it, right? They just want to know, do you understand that this is part of not the OSI model, but of their fiber channel 5-layer model?
Yeah, and I was actually looking up some other things online about this particular model, because I've never even heard of it. And it was saying like transmission protocol, that's like the FC1, and signaling, that's an FC2. So like you said, those kind of keywords and key concepts of like what we would think in like the OSI model or just basic stuff, and then how does it transport or transmit into their particular layers.
Yeah, trying to match that up. And remember, you can't really match it all up because they kind of mangle it pretty good here. But overall, though, just kind of realize that they're working on a different model than what traditional networking tends to work at as well. All right, now, Vaughn, saying that, okay, it means that we need to at least take a look at the topology of fiber channel and how it all fits together as well. So that is what we are going to talk about briefly. Now, Vaughn, on this particular diagram that I've created, there's two different models of fiber channel that I have. Now, the one that if I were actually implementing this, because I'm a simple person, it'd be the one over here on the left. And that's the one that I understand, Vaughn, okay? The point-to-point one, okay? Notice that we have a server, and then we have a SAN, and, well, that's just it. It actually talks to one. Vaughn, I can actually understand that one. That one seems simple enough.
It's like a conversation, like you and I having back and forth, and we don't have to go around and up and down and all that kind of other stuff.
Yeah, so this one seems to be fairly natural for us here. But I want you to pay attention to these labels, though, okay? So in fiber channel, like everything else, right, they have their own terminology is what it comes down to, okay? So when you actually do something like this in a point-to-point, you don't have to actually worry about some of the different terminology. Essentially, this SAN here is considered a node. So this is a node port that you connect to over here. The server that's connecting to use the services of the SAN itself, that would also, if we're doing it over fiber channel, would be considered a node port as well. But both of those devices have to be fiber channel capable and that they are directly attached. And that means that they have an actual cable that runs between them is what we actually have. So they're directly attached to that device, okay? So that's the one that we have as well, okay? Now, can this also be, so you actually see where I have this down here at the bottom, fiber channel interface on a point-to-point or a switched fabric? Ooh, now I've just thrown a new term in there, and that is because they have special, when we start talking about a switched fabric and fiber channel, these are specialized switches that essentially run the fiber channel here, okay? So if we add that in, we'll see that this port name will end up changing on those fiber channel types of switches. But we'll get there in our next little diagram that we have. Now, Vaughn, the other one that you have is over here on the right-hand side, and this is what is considered an arbitrated loop. Now, remember that with the direct point-to-point here, well, we only have essentially two devices, okay? Two fiber channel capable devices, and that's pretty much it. That's the limitation. And Vaughn, I'm good with that. But we got to realize something. In the real networking world, okay, the very fact is I probably need more and more devices actually connected together. So the way that they do it instead is that they have what they call this arbitrated loop. And this particular arbitrated loop allows us to be able to connect up to 127 fiber channel capable devices. And the weird thing, Vaughn, is that it doesn't have to be in a physical loop like I show here, where I have one cable that's connected here, this cable then is connected here, this cable is connected up here, and this one's connected back in. These could all be connected to what we call a fiber channel hub, and that is a logical loop instead, okay? So we have the capability of both of them if we actually just wanted to connect each of these devices into a centralized hub. We could do that as well. The same topology would still exist. It's still what we call a logical loop instead, or a physical one. A physical one is probably not as popular as it once was, but who knows, okay? Because it depends on how old and who's actually maintaining this thing, whether or not they want to do this. But Vaughn, now, notice that the port names has changed, okay? So in an arbitrated loop, they're no longer regular node ports, and now they're actually node part of the loop, the L here, okay? The loop ports as well. So if you're actually in an arbitrated loop, the port names change. So each one of these now actually has, well, NL ports instead. NL ports are fiber channel interfaces in any particular device that's in the arbitrated loop topology, okay? I'm putting this up here on purpose, Vaughn, okay? It's hard. Yes, names are going to change. I wish I could make them all the same for you. And even though logically to me it seems, why don't you just keep everything the same? I would love to say that, but each one apparently works just a tad bit different, and that's why you have to kind of realize that. So we're not, like I said, we're not getting into the full functionality here. Now, Vaughn, the other one, this is probably the most popular one that's there today, which is what we call the switched fabric, okay? Now, the reason why the switched fabric is actually much more popular, Vaughn, is because a switched fabric includes, well, fiber channel switches, which are probably more expensive, of course, okay? But Vaughn, notice what I wrote here, okay? You can attach up to 16 million devices to this. Pretty hefty.
That's a lot.
Compared
that would
to,
be a lot.
yeah, compared to 127, way much, yeah, a lot more, just a tad more, okay? Now, when you do something like this, this is where it gets tricky in terms of the terminology. In terms of the terminology, okay? The two switched fabric switches here. I said that again, okay? The two switches here. Now, this is part of what we call our switched fabric, okay? These ports that are directly connected to each other, these are what we call expansion ports, okay? So if you're connecting two of these switches together, you're going to use E ports to make them connect together, okay? Switch to switch, that's the way it's going to be. But if you're connecting individual pieces together, okay, that are actually doing something like what we talked about. So we can actually do point-to-point ones, or we can do the arbitrated loop just about here. But if we do the point-to-point type of connections, there are N ports that connect to, well, F ports, which is weird, okay? That stands for the fabric port. So you're connecting an individual node to the fabric, you're connecting an individual node to the fabric, and now notice, Vaughn, down here, it's the same thing, right? Node to a fabric. But Vaughn, I can also do like a hybrid if I need to. Let's say that this node was part of the arbitrated loop. Well, if I do that, I actually do connect in that a node loop port here into a fabric loop port, okay? FL port. So the terminology does make sense, except that we're not used to this type of terminology, okay? Now, Vaughn, that's pretty confusing, isn't it? It sounds like a lot of words.
It's kind of like I'm remembering like the memory game where you flip one card, you have to find the other one and remember which one is where it's located, and then that they have to match.
Mm-hmm.
So the E's are between the switches, and the F is the switch to the outside people or the nodes, and
that's the way to think about it.
Yeah.
Absolutely. Great way to think about it. Okay. Now, Vaughn, just when you think it's enough, guess what? It isn't. Okay. And the reason why is that there's actually two different names for these ports too. Okay. Notice that there is what they call a WWN name. So this is not for wrestling. Okay. This is actually stands for worldwide name as well. So these particular ports also have a second name too. Now, Vaughn, this is important for Fiber Channel because it means that we can actually use a couple of different ways to identify the different components in Fiber Channel. So we don't have to memorize these, but just kind of realize that term worldwide name, okay? So they do have different ones. So like the SWNN, those actually stand for the individual switches, okay? That's a switch worldwide name. But now when you actually talk about the node ports, those are port worldwide names. And then, of course, there's that F port here, and that, of course, is also the fabric as well, okay, if you're actually doing that. And the rest of them pretty much stay the same. Now, why is this important? It's important, Vaughn, because as we start to try and connect things together, there's two particular ways that we can connect them. We can either use this idea of this worldwide name type of idea, or there's even another way to connect this, Vaughn. So it actually turns into, oh, look at that, 3 names. There's what they call a fiber channel identifier, okay? A fiber channel identifier is now a hexadecimal number that looks like this.
but they're all the same thing.
Pretty
They're
much.
just how you've determined to name them.
And part of the technology that you end up using. So some will actually use the WWN name, some will actually end up using the fiber channel ID.
This is reminding me of like color values.
Yes.
Like you have your RGB value, your CMYK value,
Yep.
your hex value.
Yep.
So
That's
it's
it.
all the same color. It just depends on what numbering system that you're using it for.
Right.
Kind of like this.
Yeah. So I put a little bit more detail on here than what you'll probably get on the exam, but just kind of realize that it also matches up almost to the IP address. Not exactly, but fairly close. So port ID would be like a host ID, okay? Area would be like a subnet, and then domain would be like your network ID, okay? So kind of think about it like that. We're not spending too much time, but each one of these sections essentially gives us a 24-bit identifier that's normally written in hexadecimal numbers, okay, is what we're seeing here. And this is the easiest way to make sure that you understand the formatting of the FCID here, okay, which is the 0x and then the actual number here. Now, there are some specialized ones that are reserved, and this is the easiest one, right? A, B, C, D, okay, AC, excuse me, no B here. A, C, D, E, and then you have the broadcast, which is all Fs up here, okay? So, again, probably more detailed than what you needed to know for the exam, but just kind of realize that, yeah, there's 2 different ways in this connection here. Using the FCID and the worldwide names is pretty much the key. Now, along with that, Vaughn, before anything can actually send, okay, anything using this, as an example, we're going to talk about fiber channel over Ethernet and what has to happen because these use our fiber channel ports is what we actually have here, okay? So Vaughn, when we start doing this, there's actually 3 particular protocols that we have to be aware of. Okay, there is what we call, of course, the VLAN discovery. Okay, and notice what's actually happening here is between different devices. Okay, so at the beginning here, this is between what we call a fiber channel node, sometimes also known as an E node, and a fiber channel forwarder. This is a switch that also allows for the communication of fiber channel over Ethernet to happen through it. Okay, but there's also another discovery that happens between fiber channel forwarders over Ethernet, fiber channel over Ethernet forwarders. So you're also discovering those capabilities too. So in this one, the E node at this point, in other words, the sending computer if you want to, they actually try and say, hey, all right, what are the other VLANs that are out there? Because I need to know what all the other VLANs are that I can communicate with over fiber channel. The forwarder then will then respond back and tell them all the other stuff. Of course, then also the fiber channel forwarders, they have to communicate so that they know about what everything else is going on. And then ultimately then, there's a fiber channel controller that will allow for FL login, okay, F login, which is fiber channel login. I don't know why they actually dropped the I, but they chose to have the 5-digit or the 5-character name, I guess, or is what they chose. And then there's, oh, look, fabric discovery, okay? So fabric login, I said fiber, but fabric login, fabric discovery. And that's when the controller essentially communicates with the forwarder, say, hey, we're ready to log in, we're ready to do that. Once all 3 of those are established, okay, the idea of the VLAN discovery and everything else that comes on, then they start sending keep lives and keeps the connection alive at that point. And then fiber channel is ready to go. Now, Vaughn, we need to spend just a little bit of time here, and a brief little bit of time, talking about this idea of this fiber or fabric login. I'm going to say it wrong no matter what.
I think you just say floggy.
Yeah, floggy.
Because that's all I'm
I
seeing.
know, yeah.
It's floggy.
All right, so here's how it works. Okay, so the login process for fiber channel endports is what we see. Okay, so the way that this works, Vaughn, is I've went ahead and I tried to draw a connection so that we understand. Okay, so when we begin the process, each node here that has a node port, it has to begin by making sure it can contact, of course, those switches. Okay, so they begin to exchange frames with another endport device here in the switch fabric. If they want to do that, they begin by doing this. They start doing the fabric login. Okay, that's associated with just the switch itself. So those devices have to identify with the switch to log in. Now, that's not the end of the process. Once they start doing this, now what will happen is they now have logged in, and then the second one that actually happens is port logins. This is where I know this, I'm not going to say it right. End ports, letter N, port, will actually discover, oh, the other end port on the other end of this connection. Okay, so that is what it's called, floggy. I can't make this up. I wish I could, but that's so floggy. I know it's just.
All I see is like the cute little like fuzzy animals like walking down the street hand in hand. Like,
Yeah. But this is the steps, right? Floggy, and then you would think, what do you think the third one's going to be, Vaughn?
Moggy?
I wish. Yeah, no, they've totally screwed it up. This one is, Preely.
Before you zoomed in, I thought it said Phil.
Yeah, Phil. Yeah, this one is
Floggy
Phil.
and Phil.
Yeah. So this is actually the final process here, okay? And this is where sessions are established. This is when we hit FC4, and we have essentially communication between the end devices. The end ports is what we have. So there's 3 layers that have to go on here once we actually get logged in and doing what we actually need to do to make sure that it's actually going to work for us, okay? Now, in everything that we've talked about, there are some things where I went a little bit overboard just trying to make sure you understood just a little bit here, but did I even scratch the surface of fiber channel at all? Not really, okay? But I think that if you at least have an understanding of that, take a look, make sure you look up definitions to some of this stuff, because I can't go in and copy someone's book and say, here's the proper definition. I can tell you Ronnie Wong's version of definitions, which means, hey, Ronnie may be a little bit, not exactly describing it right. So check me out and make sure you actually check out yourself. Look up some definitions here and make sure it actually makes sense to you as well. But Vaughn, that will help us to end our discussion here on the idea of block access storage that we need to actually take a look at, or block storage access, that we've actually been taking a look at in these past 2 episodes. And that also means that we're ready to move on and take a look at, some file storage access too. And we'll take a look at that in our next episode.
All right, lots of great information. Always supplement. I was looking up some stuff while you're talking about things to kind of give me another frame of reference as well. So thank you, Ronnie, and thank you for joining us. But we're going to go ahead and sign off for IT Pro TV. I've been your host, Vaughn Smith.
And I'm Ronnie Wong.
We'll see you soon.
Thank you for watching IT Pro TV.